So what we're going to go through here is we're going to look at alkanes, but I'm also going to introduce you to the cyclic alkanes. This is the first of our things that we're going to be doing on hydrocarbons. So the first thing I want to do is just say, well, alkanes as a hydrocarbon are made up of hydrogen, and I'm actually not going to use these for what we're going to do today with the models, but I will with my diagrams, so I'll get rid of those. And, thank you, and carbon, which I am going to use because they are the skeleton, as it were, of it. Last year, you would have probably been told that for every carbon there were times 2 hydrogens plus 2, as it were. So you would have known that you had, if there's 1 times 2 is 2 plus 1, plus 2 is 4. So CH4 would be methane. The one carbon has the meth prefix, so it starts with meth. All right, and because it's an alkane, it's got no functional group. Okay, it's boring. It's inane. That's the way I always sort of like to think of it. Inane means pretty boring. It's going to end in A-N-E. Okay, so that because it's an alkane, meth because it's got 1 carbon only. So we can build what's called a homologous series from this, which means a series of things that are all following the same rule. So C2H6 would be our next one. So it's 2 times 2 is 4, plus 2 is 6. 2 carbons means that it doesn't start with meth, but starts with eth. No functional group, so ethane. And we carry on like this. The next one is propane, the next one is butane, and then they all follow the prefixes for shapes, so your geometry. Pentane, hexane, heptane, octane, and nonane, decane, and so on. So they start just following the names of the shapes. You need to be able to name up to 8. So you don't need to go beyond oct. All right? However, there is another way you can arrange these things so that they don't follow that general formula of CnH2n plus 2, which is what I've been using. All right? There's another way I could arrange them. I'm going to use 5 carbons to show you what I mean. Now remember, each of these holes that are shown here would have a hydrogen coming off it. I haven't had enough caffeine today, I've got the jitters. Okay, now if I have a look here, each has got 2 holes exposed, so those would be 2 hydrogen atoms. Okay, 2, 4, 6, 8, 10. So what we're looking at there is C5H10, which would normally be the formula for one of the pentanes, so an alkene with 5 carbons. But as we can see, there's no double bonds in this structure. Okay, no double bonds at all. So it must be an alkane. It's cyclic. So it's got 5 carbons. So I like to name alkanes backwards, as it were. All right. So it's got 5 carbons. Sorry, start again. It's an alkane. It's got no functional groups in it. It's just carbons, hydrogens, single bonds. So it's an ane. A-N-E. It's got 5 of those carbons. So that means that it's pentane. But I know it's not just pentane, because it doesn't follow CnH2n plus 2. It doesn't follow that rule anymore. So it can't be just pentane. So look, somewhere in it loops back on itself, so it makes a circle somewhere in its shape. Okay, you have to be a little bit creative to see a circle there, but that means it's called cyclopentane. Okay. So if I have something that loops back on itself, it's got the word cyclo in it. I could also do this and make it so that the cyclic bit, sorry, get that on the video for you as well. So the cyclic bit, as you can see, has only got 1, 2, 3, 4 in it. So that's got a different name. It's a structural isomer of this one, but now its main carbon chain is only these 4 here. So we call it cyclobutane. But to allow it to, so we don't forget about this carbon here, this lonely one out here, we'd call that a methyl group. It's a side chain with 1 carbon, a side chain with one carbon. So just like our prefix here for methane, methyl, or methyl if you prefer to say it that way. Okay, so your homework task on Moodle is actually to draw and name every single isomer you can for C5H10. That. Okay, but you'll see from either the second video we do today or the one we do on Thursday, of course there's alkenes with this formula as well. So that gets a bit more complicated. Right, so if I've got cyclics, cyclopentane was C5H10, so you'll notice that that's CnH2n, so it's got a slightly different general formula. So if they're cyclic, they've got a different general formula. Okay, and don't worry, I'm going to put this a little bit more organised up on the whiteboard for you, which we'll photograph and put on the blog, or you can copy if you want to. Copy or photograph if you want to. So I'll get a bit more organised for you up there. Okay, so that's our basic naming. I wasn't meant to go to the methyl one yet, but that's our basic naming. We have cyclic alkanes and we have straight chain alkanes like this one. Straight chain CnH2n plus 2. Cyclic ones, because you've got that extra carbon-carbon bond, which is basically the removal of two hydrogens, CnH2n. Cool. Any questions about those before we move on to naming some isomers? Okay, I'm going to go back to our straight chain because I think it's easier. This one here is quite clearly called pentane because it's got 5 carbons in a row. You'll notice it's called straight chain even though it's quite jagged. Okay, these are quite representative of where the electron clouds would be if we could zoom in and see a molecule, which we can't. But that's from our understanding, you know, they're not in a straight line. They are at, in this case, about 109 degrees apart. Okay, so that's what we understand it to be. If I take this one off the end, then I've got a 4 carbon chain. I can put it somewhere else so that the largest carbon chain is still only 4. If I put it at this end, it becomes 5 again, doesn't it? But if I put it here, my biggest carbon chain, no matter how I look at it, is 1, 2, 3, 4, or 1, 2, 3, 4. That's my biggest carbon chain. When I draw this on a bit of paper, it looks like this, because we're thinking this is a straight chain. It looks like this. I'm just going to make sure it fits on a bit of paper here. Okay, so it looks like that. Carbon, 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 so 4 in a row, and then 1 sticking up the top. Of course, then I'd fill in each hole with hydrogens. So this has got 3 holes, so I'd go 3 hydrogens. This one's got 1 hole, so I'll put a hydrogen on it. This one's got 3, so that becomes 3 hydrogens. That one there is H2, and that one's H3. So I can draw it like that. So what I'm looking for is my largest carbon chain. No matter how I put it, it's either that or that. Either of those. So what I do is I number them. 1, 2, 3, 4. And I number them backwards as well. Okay, and you'll see why I do this in a moment. 1, 2, 3, 4. The reason I do that is I'm trying to find the lowest number that my little extra bit, this little side chain thing here, is on. It's on the carbon with either a 2 or a 3. I've got to choose one of those. Is it on the number 3 carbon or is it on the number 2 carbon? I choose the lower of the numbers. If they're the same, you know what it is straight away, but I choose the lower number. So this one becomes 2-methyl, meth because it's got 1 carbon in its side chain, 2-methyl, and then 1, 2, 3, 4, so butane. All right. Now, if I go to cyclics, things get a bit more complicated. I'll show you this with cyclopropane, which has got 3 carbons. So bear with me on this because I need the bendy ones because there's a lot of stress on the bond in this one. Cyclics do something a little bit funky. This will really help you with your homework as well. This that I'm about to show you. Okay, so you can see there's quite a bit of bending in there when I do a triangle one. I've got to put two more methyl groups on there, or an ethyl group if I want to. There's a big hint for you. I could put an ethyl group, so that's CH2, CH3, but I'm not. I'm going to do 2 methyl groups here. Okay, so I've got to stick them on. I could put them both on the same carbon. Okay, so it looks like that. You want to sort of see that clearly enough without having to rely on looking at the video later? Cool. Okay, I'll get you to make this later anyway. If I have a look at that, my biggest carbon chain is the cyclic bit. So it's cyclopropane. All right? It's got 2 methyl groups on it, so I can't just say methyl, I have to say dimethyl. So again, I like to name this backwards. So bear with me while I use some pretty cheating ways to do this. You'll see I do a triangle for this bit here, and then I've got my 2 CH3s sticking off the top. If I number it, this could be number 1, 2, or 3 because it's a circle. So who's to say where the start of a circle is? We don't know. It's at the same place as the finish of it. That's all we know. So this could be 1, 2, or 3. Well, because both methyl groups are on it, we know it's number 1. Yeah. Cool. So this will be number 1. Either of those can be number 2, and either of them can be number 3. There's nothing on them, so who cares? So being 3, I'm going to say, oh yeah, it's cyclopropane, because prop, and if you guys haven't heard my little mnemonic for that, must eat peanut butter, meth, eth, prop, bute. Right, nice easy way to remember it. Or for those that have allergies to nuts, mustn't eat peanut butter. We've got 2 methyl groups, so we say dimethyl. But there's a wee problem here. Those methyl groups don't have to be on the same carbon. They could be on different ones. So I need to say which carbon they're on. They're both on number 1, so it's 1, 1 dimethyl cyclopropane. Quite a mouthful. All right? Now here's where things get really cool with cyclics. Well, I think they do, because I'm a bit of an organic chemistry geek. I could move this to one of the neighbouring ones. And if I have a look at this, I'm going to put it in the video and then I'm going to show you. Have a look at this. I can't twist that chemical bond because it's cyclic. What would you have called that if it was an alkene? It's going across the bond. Trans. And we do for this as well. This is a trans isomer because if this bond broke and went on the top, it's cis. Okay, so there's actually 2 possibilities with what we'd call 1,2-dimethyl cyclopropane. Okay, so alkanes, sorry guys, they now, if they're cyclics, can have geometric isomerism. This is called geometric. Different geometry of the molecule, but the same structure. You'd still write it out the same way. Okay. So it's too hard to show with 2 dimensions, but with 3 dimensions it's really easy. And that's why you've got the molecular models. Are there any questions there before we stop this?
When it was in the triangle in the first one, how is it only 3 the longest chain if you could go down
right.
like that?
Okay, you can't include these ones. Okay. They are side chains. Okay, the majority of the functionality comes from it being a cyclopropane. Okay. Really good question. Really good question. Anything else? Okay, I'm going to stop there. I'm not going to do the alkenes one today. I want you to have a play with making all the cyclics that you can of C5H10 and see if you can actually try and name them. Which ones have cis and trans, which ones don't. They don't all, by the way. So you'll see it's quite interesting.